Okay, so here's a quick lesson on variables. So what is a variables? If you have taken algebra, then you should know what a variable is, but if you have not, don't worry. A variable is a placeholder for a value. It could be a numeric value, like a number, or it could be a string value. A string is a string of characters, kind of like text, okay? And Boolean. Boolean is just a value that can either be true or false. True, false, 1, 0, yes, no. That's a Boolean value. And we use variables a lot in math, science, and programming. So let's give an example, a numeric example. If A is equal to 10 and B is equals to 20, what is A plus B? Okay, so all we have to do here is just substitute A with 10 in here. So 10 is, A is 10, B is 20, so it becomes 10 plus 20, which is 30. So that's a very easy example. All right, on the next example. Okay, well, we have a numeric value. Okay, so let's say our dinner costs $50 and we want to tip, the tip rate is 20%, which is represents 0.20. The tip is equals to the dinner cost multiplied by the tip rate. So what is the tip? So this is very easy. You just substitute dinner cost with 50, put 0.2 here, multiply it, and I think that is 10, something like that. All right, so you live with $10 tips here. Okay, so next, this is a more complicated example. This is your final exam. So let's do a aerodynamic example, right? So if an airplane is flying with a velocity of 150 feet per second, and the wing have a lift coefficient of 0.25 with a surface area of 175 square feet, the current air density is 0.002378 slug per cubic feet. Yes, slug is a measurement of mass in the English unit, okay? Probably haven't heard of it much, but that's what it is in the engineering world. Okay, so anyway, how much weight can this airplane hold? Okay, can it support, including itself? Okay. So first thing we need to do here, this is really complicated, right? But it's actually not. It's very easy. So why don't we look at the very simple here? So symbol here. So we can see L is lift, A is area, R, which stands for rho, is air density, V is velocity. And the equations to calculate lift is L equals to CL, which is the coefficient of lift, multiplied by your air density, multiplied by velocity square, multiplied by area, and divide by 2. Okay? So first thing here, simplify the problem. Let's pull out all the variables. What is V? So we can look at here, velocity is 150 feet per second. So 150 is here. What's our lift coefficient? Well, lift coefficient is right here, 0.25. Area is 175 here. And then rho, our air density, is 0.002378 slug per cubic feet. Okay, and so we can just fill this table out. And it becomes something like this. And then how do we calculate lift? Well, okay, so it asks us how much weight can the airplane support. Basically, the airplane can support as much lift it can generate. So weight equals to lifting force equals to L, which is equals to this. So if you plug and chuck everything in here and put it in a calculator, you'll get something like this: 1,170 pound force. Okay, not that hard. It's pretty simple. Okay, so next, let's talk about string variables. So as I mentioned before, string is a sequence of character, basically text. Everything inside a string must go inside double quotes like this. Okay, you must do that. If you don't do it, it becomes a variable and not a string, and computer will freak out. So let's give an example. My name is Billy Howe, so I put this inside quotes here. What's my favorite food? Favorite food is equals to fried rice. All right, so let's give an example here. If we say my name, substitute my name here, love to eat, and then substitute your favorite food here. So this sentence become, my name is Billy Howe, right? So Billy Howe love to eat fried rice. See? Okay, that's not too hard. That's pretty simple. Alright, next. Now we're going to talk about Boolean values. As I mentioned before, Boolean values is pretty much a variable that can only have two values. It's either true or false, which is also yes or no, which is the same as 1 or 0. You know, computer operates on 1 and 0, right? 1 is on, 0 is off. So when it's on, it also means true. Off also means false, also means yes and no. Basically, it's like that. So some example, you say A is equal to true, B is equal to false, and here's a little bit more complicated. We can put a comparison statement here. C is equals to 1 plus 1 equals to 2. What does this mean? So let's ignore the C right now. Just focus on this statement. 1 plus 1 equals to 2. So this is the comparison operator table. You can see when we do 2 equal sign, we're comparing the two values, the left side value and the right side value. If they're equal, then this statement is true. If they're not equal, then this statement is false. So here we have 1 plus 1 is 2. Is 2 equals to 2? Yes. So that's a true statement. C is true. Okay. And you can also use other operators here. For example, we have the not equals to operator. We have the not operator. We have the greater than, less than. We also have greater than or equals to, and less than or equal to. You just stick a equal sign here. All right. Okay, let's move on. Okay, let's give an example. If let's set A to 5 is greater than 10. Is A true or false? Well, 5 is not greater than 10, so this is a false statement. Okay, so this is false. And B is not A. What does not A mean? So A is false. Not false mean true. So B is true. Does that make sense? Alright, let's do another example. So example number 2. Let's set A equals to 5 is not equals to 10. Is this a true or false statement? 5 is not equals to 10. That's a true statement, right? So A is true. Alright, so B is not A. B is not true. If it's not true, then it's false. So B is false. Okay? So those are two very simple example. Now let's go example number 3. You can do this with text as well. If direction, so let's set direction equals to up, okay? We are moving upward. So let's set A to its direction equals to down. Is this a true or false statement? Well, we know that direction is up, so direction is not down, so A is false. So you can see here, our logic comparison statement can also be applied to numeric and string value as well. Alright, now let's say what if we have two statements that we want to combine together. So we use something called the truth table. For example, if A is true, B is false, C is A or B, then what is C? Okay, let's take a look at this table. Well, let's not take a look at the table. Let's think about it first, okay? If I give you an example, my name is Billy and I am a girl. Is that a true or false statement? Well, that's definitely false, right? Because I am not a girl. So, but my name is Billy though. The first part is correct. It's true, but the second part is false. So that's why it made this whole statement false, because I said, I'm Billy and I am a girl. A is true, B is false, so therefore the whole statement is false. The only way for the AND statement is if both item A and item B are correct. Now let's change this up a little bit. Let's use the OR statement here, okay? Let's just say, my name is Billy, or I am a girl. Is this a true or false statement? Actually, this is a true statement, because for an OR statement, only one of the conditions have to be true. So you can see the first statement is true, my name is Billy. Second statement, I'm a girl, is false. So therefore, this is a true statement because one of them, either condition A or B, is true. So for the OR statement, just either one of them have to be true. The statement is true. In comparison with AND statement, which the only case when the situation is true is with both of them is true. All right, let's do some more example here. Let's give an example relating to computer game design. So for example, let's say our player touch the enemy, contact the enemy. If that's true, and then he has 0 health point. It's false. 0 health point is false. So basically, what I'm saying is like, okay, your player touched the enemy, but he have more than 0 health points. What's gonna happen, right? So the game rule is like this: game over is equals to enemy contact or 0 health points. Okay. So let's so this is the statement right here. Okay. This is the rule that we established for having a game over condition. Let's consider this scenario. The player touched the enemy, so enemy contact is true. 0 HP is false. The player don't have 0 health points. So is the game over? Well, yes, because this is an OR statement, so only one of those have to be true in order for a game to be over. Since the player touched the enemy contact is true, game is over. So game over is true. Alright, let's change this up a little bit. What if this is false? If enemy contact is false and 0 HP is false, do we have a game over condition? So in other words, let's say our player did not touch the enemy and our player do not have 0 health points. Is this a game over condition? No. We don't have a game over condition because none of them are true. Alright, let's consider this. Enemy contact is false, but 0 health point is true. Is this game over condition? Yes, because we have 0 health point, and the game over condition say that if the player contact the enemy or if there's 0 health point, then it's game over. Since we have 0 health points, game over is true. Okay? Alright, let's go to the next example. Let's say our player need to pick up a sword the player need to pick up the sword and click the attack button to attack the character. Alright, so this is the government statement. Governing statement. Attack is equals to character pick up sword and keyboard space pressed. Okay, so let's consider this scenario. Our player pick up sword is false. That means the player did not pick up the sword. But then you hit the space bar, what would happen? Well, to be able to attack condition, player picked up sword and keyboard space pressed. This is false, this is true, end statement, so this become a false statement. We do not attack. Why don't we attack? Well, we don't have a sword, how do we attack, right? Okay, so let's switch this up a little bit. Let's say that we'll make this true and make this false. So our character picked up the sword, but we did not click spacebar to initiate the attack. Are we going to attack? No, because you need to pick up the sword and click spacebar to attack. So this is a false statement because only one of those are true. Alright, let's now consider another case. If the character pick up sword is true and keyboard space press is true, do we have an attack condition? Are we attacking? Yes. The player grab the sword and you click attack button, the player will attack. That's how it works, right? Good. I hope you understand this example. Let's move on then.